Hello, everyone. Good evening, good afternoon, good morning, depending on whichever part of the world you are joining us from. Thank you so much for your support to help the community grow. Today, we are organizing our 44th meetup by our community Kaggle Days Meetup Delhi NCR. So today we have a very special guest, Ishika. She is a Kaggle Notebooks expert and is a data science analyst at Data Technologies. She would be talking about a very interesting and very insightful topic about the fundamentals of A/B testing, and we think this talk can be of great importance to students or to professionals who are just starting their career, because this topic holds a lot of importance when you go into the industrial applications of data science. Over to Ishika, and I am hopeful that this session becomes a lot more insightful to you with her learnings. And feel free to ask your questions. We will be taking the questions at the very end, and in case we can't answer any question during the live, we would be definitely be happy to answer them post the session. Over to you, Ishika. Thanks.
Thank you so much, Ayan. Hi, everybody. This is Ishika, Ishika Johari. So, little bit about myself. I'm currently working as a data science analyst at Dell Technologies. It's my first year, so I'm also pretty new to it. And yeah, I just graduated last year, did my BTech in computer science, computers and communication engineering. So, about A/B testing, before we get into it, my relation with A/B testing comes from my work role itself. Um, the role I'm currently in is something that I got to choose before joining. And A/B testing is something that intrigued me when I got to know about the role. And even though I don't directly work into the analysis of it, I work inside the team which does it and I support them. So, yeah, this is just me going through the fundamentals of what I have also learned. And I think let's get started. So, the agenda for today would be just give me a second. Yeah. So the agenda for today is basically what I want for you guys to take away from this session is how how the intuition and the statistics behind A/B testing works. You could easily Google what A/B testing is, and there could be thousands of sites explaining you the definitions and the derivations. But what I want to do is just kind of provide an overview and kind of just in layman terms what the statistical intuition behind all of that is. I will be going through the terms in statistics, and I'll also be explaining a bit of a brief about Bayesian A/B testing. Um, Having said that, Bayesian A/B testing is different than the one that I'm going to massively show here because what is widely used in the industry and is more used by default, I could say, is frequentist A/B testing. It's based on frequentist statistics. And yeah, these are the main overall things that I'll be covering today. So yeah, going ahead into frequentist A/B testing. So, what is A/B testing basically? It's basically a way for companies or organizations or websites or large bodies to basically compare two functionalities and, in a sense, kind of try to gather which one is better. But you and me could easily say that, okay, maybe a specific person's favorite color is red, and the other person's favorite color is yellow. So it could depend on the person's personal preference, what kind of colors or features or different functionalities they see on the site, and what intrigues them. But talking from a point of statistics, that's not how it works because we're not talking about one person here. We're talking about the whole population. And population is something that I'll be getting into later as well. So as you can see on the screen here as well, you can see on the right, we have these two laptops and there are different colors for different features and two different buttons. So this is kind of in a sense of how it works from a very high level overview. For example, over here, the button has different colors and we basically test these both versions and see which one works the best in terms of revenue and everything that the organization has defined that it wants. And over here also we see something different than the one above. It's just different content explained in a different manner. So yeah, that is the sense of A/B testing, and it could be used for marketing, product design, as it says here, user experience research. Same things mostly, more or less. But if you go into the detail, they differ quite a bit. Um, and then there could be three purposes for A/B testing, right? So there's design, content, and functionality. So basically, when we talk about design, we talk about color schemes, layout, and typography. This helps us which design is more visually appealing. As I mentioned, the colors, So, but visually appealing to the target audience and not one particular person. And then, of course, our goal is to have higher conversion rates. That's the general goal for most organizations, anyway. Then, coming down to content, content is basically um, different headlines, copies, and images. So, it helps us determine which content resonates better with the target audience. It could be the written matter of the site and how you present your knowledge, all of that stuff. Functionality is basically for us to test different features such as buttons, forms, navigation. All of these are very closely related, but still they do have some differences. For a particular A/B test, it could be easily possible for a particular A/B test to have all three of these, or only one of these, or maybe a combination of the three of these. And there could be more types as well. So yeah, moving ahead. So why do we need A/B testing? Basically, A/B testing is it's a data-driven process, as I mentioned earlier. It's statistically driven. So basically, when someone comes up to you, someone higher in authority comes up to you and says, "Why do you think this is better than the other thing?" So you can easily say that because this is statistically significant. This is what we tested. So, and this is what we observed that the general population is tending towards. So yeah, that's the gist of it. And coming to these points on the bottom, of course, the main goal for most organizations, as it is to gain revenue, it mostly is to increase conversion rates, revenue, and sometimes it's also to analyze user behavior for something just for research purpose or going into behavioral sciences basically. And so basically it helps you understand the target audience, right, as I mentioned. So each visit is unique and it varies with the intent and expectation. So you can understand which elements resonate more with the particular segment of your audience. Analyzing your marketing budget. So you can analyze where your marketing spending gets the highest returns. The test you paid, you can A/B test paid active ad campaigns and save thousands by scrapping copy or design that does not generate clicks. So if you hadn't conducted these tests, you wouldn't have known these, right? So, and again, it helps develop data-driven insights. So it works in a real-time environment where your visitors can give you feedback. So as you are monitoring the changes, you get the statistically significant data, and there's a way of mathematically proving all of these certain statistics as well, and it's really reliable, and it's been used across generations basically. Then reducing bounce rate. So bounce rate is something that I'll be diving into later. But yeah, basically it helps. Bounce rate is something which we want to be less, so it reduces bounce rate, and it's basically how many of the users are just landing on the page and just not even exploring anything and just leaving it. So yeah, there you go. This is why mostly organizations conduct A/B tests, and there are many more reasons as well. But these are the gists. Coming to the types of these tests, the most default A/B test, which the one that we usually refer to when we say A/B test, is called split testing. Then there are multivariate tests and multi-page funnel tests. So again, as much as with design, content, and functionality, uh, a particular test could have all three of these also, and it could have only one of these or a combination. So how it works is split A/B tests only test a particular thing in the page, as we saw in the example before, like the particular button color. or it either tests the entire page as a whole. So it considers the whole page as an entirety and doesn't consider multiple things. Of course, the opposite to this is multivariate. So we test multiple things simultaneously and we define them. So, for example, over here you can see there could be an example where we're testing the headline, image, and CTA position combinations together. CTAs are basically called call to actions. They're buttons or anything which calls the user to an action. It could be a button or a link. So basically, where we define two or more or even more variables, and we analyze all of those variables and a combination of them collectively. That's called multivariate. And then for multi-page, this is basically when we need to test changes across multiple sites or multiple pages of the website. Sorry. So basically, for example, if you consider a general e-commerce website, the landing page would be the one where the user lands, most probably where most of the users land, if you consider if they go directly through Google to the main link, and then they go down to the funnel. So this is called a funnel, and the funnel is basically a way of depicting because every at every stage of the different pages of the website, there's a churn rate, which basically means there are specific users leaving that page. So only a few of us actually make it to the payment page, or some of us usually just add it to the cart and leave it for later. So this is basically depicted to show us that churn rate, and this is important because a lot of analysis are done keeping into consideration this churn rate itself. So it's not necessary that if 50% of our ideal target audience lands on the landing page, then it's not necessary that all of them make it to the payment page as well. And some may never do, and some may do that after a very long while, right? So this is basically what that is. And multi-page funnel types are basically when there's a particular feature that you're changing for every page of that funnel. So, going ahead, we'll be diving into the statistical intuition behind the whole process of it. As you can see, we have a word cloud on the left here, and what my goal would be to make it easy for at least people who would not know a lot of these terms to be able to correlate a lot of them in terms with A/B testing and hypothesis testing, which we'll be diving into. So over here, we'll start off with some terminology. This is some very basic terminology which is used in all of statistics. And of course, just a disclaimer, I know a lot of you might be knowing these from way earlier, but still, I'm just assuming no one knows anything. And so, yeah, diving into the basic terminologies, we have population and samples. So, population is basically our target population. It doesn't have to be the whole population of India, right? If there's an e-commerce website for India, it doesn't have to be the whole population. Our target population could be, for example, the users who use internet, right? So people who don't use internet would not be even exposed to that kind of to that e-commerce website in the first place. So basically, our target population is the one that we'll be considering. For our example here, let's consider as I mentioned right now that there's an e-commerce website and people who use the internet in India. Those people are the target population. Then the reason we do all of this in the first place is that there's no way that we can get the data or observe the data for all of the people in this target population. So that's why what we do is take samples, and there could be one sample, or there could be more than one sample, and that depends on the number of recipes that we have. Again, I'm sorry I didn't mention this before, but recipes are basically different versions of the comparisons that we're doing in an A/B test. It could be two, it could be more than two as well. And throughout the course of this presentation, we'll be considering the recipes to be two for simplicity's sake. So we'll have a control recipe, and then we'll have a variant recipe or treatment recipe. So we have two recipes, and for that purpose, we'll be taking two samples. So these samples are like a subset of the target population that we're considering. And yeah, the sample size is something which is a very important criteria for us. The sample size should be large enough for us, and the experiment or test can only have desirable statistical power if the sample size is very large enough. There's also a term called minimum detectable effect, and we'll be getting into that later, and that is also what is related to sample size. So, also another point, how it's done basically in practical terms is that suppose a user enters the e-commerce website. Suppose you go to a specific e-commerce website tomorrow, you won't be even knowing if you're qualifying for a particular sample of a particular A/B test. So suppose you see on the A/B test on the e-commerce website that there's a button called Pay Now, and Pay Now button is yellow in color. It's not necessary that a specific random person from another sample would see the same button in the same way that you do, because it's very possible that you qualified for a particular A/B test and you both are in the different samples. So basically, how it works is that when a user visits a site, there are cookies assigned to that particular visitor. Of course, this remains in your browser history until and unless you clear your cache. So basically, it's how the website identifies a particular user, right? So cookies are how we define a particular sample, and we just keep dividing people into separate samples. So that is what actually happens in terms of dividing the population into samples. Then over here, we have some metrics and terminology. So on the left, you can see a lot of metrics. So what I mean by metrics here is there are many things that are really important for before even diving into the A/B test, we need to define what the metric for that particular test we would be considering as. So these are some of the general metrics that usually are used in the industry, or may be used, or maybe there are more also, not that I'm aware of. But basically, conversion rate is orders by visits. So this is the primary metric that a lot of organizations use. Click-through rate is again basically a probability of if the user will click the particular CTA or not. So it's a Bernoulli trial, right? So there's a success and then there's a failure, and there are only two outcomes basically for the click-through rate. Exits and bounce rates. So bounce rates, as I explained earlier, are basically when the user visits a site. In intuition, it's that when the user visits a site and doesn't engage into many CTAs or many features on the site and then just exits. So exit rate is just something, basically bounce rate is a subset of exit rate, and exit rates encompasses a wide range of exits, right? So it could be that the user engaged and then left. So that's exit rate. Um, so yeah, these are calculated by exits and bounces. And where this data is gathered from is there are a lot of third-party applications that help, and a lot of analytics tools that help with this. Adobe Analytics is one, Google Analytics is one. And then there are a lot of softwares that organizations use to gather this kind of data in the first place. Then we have AOV and RPV. AOV and RPV are also very important metrics, and these could be called different names in different organizations. But basically, it's average order value, so revenue by order, and revenue per visit is revenue by visits. So revenue by order would be the revenue for each order made. So the average revenue basically for each order. And then revenue by visits is revenue per particular visitor or particular visit. We won't be diving into these terminologies till yet. We'll be going into these later. So moving ahead, we have the MDE and samples. So basically, as I mentioned earlier, minimum detectable effect is it's necessary to calculate the minimum required sample size. This is basically something that has to be defined before we go into a test, and it varies on a lot of factors. It varies on how the opportunity cost is, if implementing the test is costing a lot, and our probability of gaining the conversion rates in a favorable scenario is less, Then basically these are the kind of examples that influence the what we said the minimum detectable effect as. So and also it should not be confused as the smallest possible effect. What I mean by effect here is effect would be the difference in what we observe between the two samples. So, just on a very high level overview, it's the difference, and these are the two samples, and these are the means of the samples. We'll be going into this later. So, yeah, so it's not to be confused. It's not the smallest possible effect. It's just the minimum effect size that should be achieved. So there's a difference between the two, right? So minimum is it's just the bare minimum that has to be achieved. And then also MDE is not the effect size that we are expecting or want. It's not at all what we want to observe. It's just something kind of like a threshold that we set for us to determine this sample size through. So why does it matter? Again, it matters because suppose, for example, if you are standing in front of a conveyor belt and the quality checking screws that I mean there's basically a quality check being conducted on screws. So if you want to prove that the quality of 50% of the screws being produced was below standards, how many screws would you examine before drawing a conclusion? I mean, it would be most probably less than if you wanted to prove 2% of the screws, right? So there's a difference when you have to prove that there's a difference in quality for 50%, or if there's a difference of quality for 2%. So basically, this 50 and 2% thing is the effect that we're talking about here. And the smaller the effect, the more samples we need to collect. And that is basically an increase in the required sample size requires us to run the experiment for a more extended amount of time. So yeah, smaller your MDB, the larger the sample size required to reach the statistical significance. And also the large, in general, overall, the larger the sample size, the larger the time the test has been running for, the better. Because the larger the data, I mean, that'll be just more reliable data for us, right? And the statistical power for the test would also be really large for large samples. So, hypothesis testing is basically a really important concept in statistics. And it basically evaluates two mutually exclusive statements about a population to determine which statement is the best supported by the sample data. These two statements are called null and alternative hypothesis, as you can see on the screen. The null one is on the left, and the alternate is the one on the right. So, as you remember, in India, in mathematics, during our school days, there used to be a whole way of proving mathematical derivations and certain statements that we used to get in questions also, right? So you could broadly just consider this as that, so that we assume something, and then we, based on that assumption, we assume everything based on that. And then if our results are not matching or there's some discrepancy, then we basically prove that our assumption was wrong, right? So this is a basic gist of what hypothesis testing is overall. And there are always only two hypotheses. And for our case, it's d is equal to 0 and d greater than 0. D over here is the difference between the samples. Uh, this is the case considering A/B tests only. Hypothesis testing can range a lot of different tests, but for A/B tests, we consider D, which is the difference between the both samples, as 0, because what we're essentially assuming is there is no difference between those samples, right? So why? So that's the assumption, and then we go from there and assume everything, and then we try to disprove it basically. And another thing with hypothesis testing is that we never accept the null hypothesis. We always either reject the null hypothesis or fail to reject it. That is because, I mean, we are assuming something, but we also know that our goal is to prove it wrong, right? Our assumption is wrong in itself. We know that. So, practically speaking, it would be wrong of us to say that we're accepting something which is negative, right? So, we can't accept the null hypothesis, therefore. So, yeah, going ahead. So this is where our concept starts, right? So basically, you can see the data observed here is for two groups. A is our control group and B is our treatment group. And basically, these are the specific. This is just an example. So suppose 194 people converted and 223 people converted for treatment. But this was based on the number of visits that both of these samples also had, right? So the CTR, which is the conversion rate here, is 19.24% for this and 22.47% for this. So, I mean, on an overall basis, just from the naked eyes perspective, you can say that, okay, so the treatment was better, right? Because we got more conversions, but it's not statistically significant yet because we don't know if it is. And that's also because if you see the intuition behind it, there are 1,000 people visiting the control, right? And there are only 900. It could be very extreme also. There could be 1,000 people here and there could be 200 people here and there could be 100 people here. So it could have had a 50% conversion rate. But because there were so many less people visiting the treatment, we can't easily say that it's statistically significant, right? And statistical significance is a definition that is really important as well, and I'll be defining that later. But yeah, statistically significant for now is just you can say that it's just like a stamp of approval that okay, this is the correct thing, and what you really think is, I mean, your gut version of this whole thing is actually confirmed and supported by empirical data behind it. So yeah, the question we ask here is basically if the difference observed is a random observation, or do they differ to such an extent that we want that it can't be that we can't be confident that the difference is random, and hence we will have to reject the null hypothesis. So basically, what I mean by here is, uh, see, the differences will arise anyway, right? So as we observed here also, even if you take 10 samples for the control and 11 samples for the treatment recipe, it's never possible that you'll always get the same data. So it could be possible that the observation that we observe, basically the final observation that we get over here, which is the conversion rates for these both, it could be possible that it's completely normal for this to happen, which is what we call random. So it's completely random that that happened. Or the other possibility could be that it's so extreme, the difference is so extreme that we can't say that it's like, possible most of the times that we observe it. And we'll be quantifying this ahead. So let me move ahead. CLT is basically central limit theorem, and the reason I'm giving a gist behind this here is because the whole concept of hypothesis testing is based on the central limit theorem. So basically, what happens is there are many different kinds of distributions, and I won't be diving into this in detail. But suppose there's like a distribution of height of people, height of men and height of women. So it could be like this, it could be like this, it could be like this. It doesn't matter how it is exactly, but basically, for a specific scenario, there could be a different kind of distribution, right? But the thing is, for every different scenario, we can't be we could be going into so many different possibilities of testing that particular scenario had we not had the central limit theorem, which basically says that if we're sampling those populations, basically the mean of all of those samples, the means of all of those samples when plotted together, it will result into a normal distribution. So, and then since we already know a lot of rules about the normal distribution and statistics as a whole, it's easier for us to derive conclusions based on that. And then we can go ahead and conduct many statistical tests based on our conditions. But the gist of central limit theorem is that we need to approximate the population mean because we don't know it. So for a website example, going back to that, if our target population is the internet users of India, right? Uh, and then we get samples from the users that visit that particular e-commerce website, then we can easily estimate the mean of that population, the population being all of the internet users, right, which we don't even know about. So we can estimate that mean if we have enough sample data. And yeah, I mean, that's basically the gist of it. But the condition is that we have to have a lot of sample data. So as I mentioned earlier, the size of the sample data is again really important for that. And this is just some terminology behind it. So The thing that I'm calling here this normal distribution, it's called the sample distribution of sample means, because it's basically a distribution of all the means of the samples that we took. So just pay attention to this closely. If this is our sample, sorry, if this is our population, I'm sorry, my bad. So if this is our population and we collect a sample from this, and we collect many samples from this, so the means of all of those respected samples will follow this distribution, and this is called the sampling distribution of the sample means. The mean for this is very close or basically the same as the original distribution of the population, basically, which is this. And this is the normal distribution. This is also the normal distribution. The more data we have, the more accurate the distribution gets, and the more accurate the peak of the graph gets as well. So moving ahead for the concept, over here you can see two normal distributions. And yeah, so these two normal distributions are basically observed from the two samples that we took for our e-commerce website experiment. And suppose this is the control and this is the treatment. These would be the means of the samples that we took. This is the difference between them. And this is basically what we were referring to when we defined our null and alternate hypothesis. So the distributions of the samples that we collected is normally distributed, and this is just a specific example. It doesn't have to be this specific way. But yeah, for this example, this is the difference that we have. And from here on onwards, what we'll be evaluating would be the distribution of this parameter. And this is called the test statistic. So the test statistic for A/B testing is the difference between these means. It's not the same for every scenario, but for A/B testing, it's this. And then the sum of the normally distributed variables is also normally distributed. This is something that has been derived statistically, and I won't be going into the derivation right now. So yeah, this B cap follows a normal distribution, and that is also called the test statistic. So yeah, why do we need to know all of this, right? Going ahead, explaining that question a bit, would be that we want to find the evidence, enough evidence to reject the null hypothesis. So, as I mentioned, our goal is to reject the null hypothesis, and we know that it's not correct, but we still assumed it just for simplicity's sake, and that's how statistical hypothesis testing is done by default. So, to reject that, that is the whole goal of this scenario, and we do this by showing that the mean of the alternative hypothesis will be located at a different value than the mean followed by the null hypothesis. And this different value could be easily random, right? The thing that I defined earlier, that it could be it could be random, that the difference between them is quite likely to happen, right? But in some cases, it also could be that that difference is very extreme or large enough for us to doubt it and say that, okay, this is probably not likely to happen. And that is the whole scenario that we're trying to prove here. So again, this is our null and alternate hypothesis. So, coming back to the terminology, these are some of the terminologies that are really important for us to go into the sections ahead. Statistical significance, again, as I mentioned, is it's like a feeling of it's feeling that a certain thing is unlikely to happen at random. And for this scenario, it would be that it's unlikely to happen. And it's basically for us to say that, okay, now we can statistically say that this thing that is happening is really, really, really rare to happen. And so it's highly unlikely. And yeah, and we don't have enough confidence to say that. So confidence again is closely related. It's another way to define probability. So a way I can define statistical confidence is that I could say that I'm 95% confident that this is unlikely to happen if we assume the null hypothesis to be true. So if that is the case, then there's also something called as the significance level. Significance level is the opposite of confidence. It's 100 minus confidence. So significance level, which is the most usual one used, is 5%, and respectively confidence is 95. Some people use 10% significance and 90% confidence. And some people also use 1% significance level. And that is an example that you could observe in medical trials, because why we use 1% confidence, the intuition behind that for medical trials would be that we need to be really, really sure that what we're observing is really unlikely. So we set it up as so that we don't have get a lot of errors, which are basically a type 1 and type 2 errors. These are two types of errors that I won't be going into today, but you can search it up, and it's basically just a false analysis of a whole result or conclusion. P-values are basically a strength of evidence in support of the null hypothesis. A p-value is less than, if a p-value is less than the significance level, then we reject the null hypothesis. So going by 5%, if we take that as the standard for this presentation, then if the p-value is 1, 2, or 3, or 4, then or anything else in between, then we reject the null hypothesis, meaning that basically this particular scenario is so rare for us to observe that it could only happen 2 or 3% of times, and hence we reject our null hypothesis that these two cases are the same. Um, Going ahead, sorry, critical value. So the critical value is, again, it's just a point on the on the x-axis of the distribution of the test statistic. Uh, if our observed test statistic crosses that or is basically less greater than that, then we say that we can reject the null hypothesis. So, test statistics, right? So, there could be a lot of statistical tests that we conduct based on certain conditions. And over here, the ones that we're considering, it's just a basic, simple scenario, just a z test and t test. And there could be many more as well. But we're just considering these two for now. And basically, how it happens is that we consider and take a z test if we have the population variance. But for A/B test specifically, since we don't have the population variance or standard deviation, which basically intuitively standard deviation or variance means how far the data has been spread across. So we don't know that for the whole population, right? Because we don't have the population data. So for that purpose, we use the t-test. And also, if there are greater than 30 samples, then we can use the z-test or the t-test, because when it becomes greater, or when specifically when n is equal to 100 or it reaches or approaches 100, then if we use z-test or t-test, it doesn't matter. It's both of them are the same. And yeah, the distribution of our estimate will be a normal distribution, as we mentioned earlier. Our estimate here being the d value that we were considering earlier. Sigma over here is the variance, and sigma square by n. Sigma p basically is the it's the standard deviation of the population, and then sigma square is the variance. And sigma 2 over here is the one that we're considering for a particular sample. And since we don't know the population standard deviation or the variance, we look into standard error. It's basically the same thing as standard deviation. I shouldn't say same, but intuitively you can assume them to be similar things. It's just that the standard error is the standard deviation of a sample run. It's not for the population, so it's called standard error. And there are specific formulae behind all of these tests. So z-test has its own formula. T-test also have their own formulas. But again, I'm not going to be going into formulas today. But yeah, you can easily find them online. And the basic gist is considering that we don't know the variance, which I just explained. So now our next step would be to decide if we should reject the null hypothesis based on our significance level and sample data. Our sample data being, for our particular example, conversion rates for both of the samples. It could be AOV also, it could be exit rates also. But for this particular example, we consider conversion rate as the metric. So that is the metric that we're considering, and the data, therefore. So to compute the test statistic, if the test statistic, which again is computed by the formula, if it's greater than the critical value, then we reject the null hypothesis. And if the test status, or if the p-value is less than alpha, which is 5%, then we reject the null hypothesis also. So you can see over here there's a diagram depicting the test statistic for a particular situation. Over here, the test statistic lies in the greater area, and it's not greater than the critical value. It's less than the critical value. Therefore, we fail to reject it, or we do not reject the null. And significance level again is 5%, or critical value, as you can see. Yeah, going ahead, we again have a few graphs over here. So again, this is the p-value. The observed data point could be anywhere, and if the p-value is less than 5% for this specific scenario, then we reject the null hypothesis. As and when the data, this is basically a probability distribution graph, and if the data is observed here or here, then the probability for that specific scenario happening would be very, very, very less, and very rare, hence. So basically, the rarer the thing that the scenario that we have is observed to be, the easily we can reject the null hypothesis. And we can see that through the graph easily, yeah. So there are specific kind of tailed tests that we have. There could be a one-tailed test or a two-tailed test. Um, a lot of organizations use one tail. A lot could use two tail. It totally depends on what the conditions the particular organization or entity has set for themselves. And I can give an example. So, for example, for a one tail test, the hypothesis could be that the null hypothesis could be that there is no difference between the samples observed. And then the alternate hypothesis could be that so basically the alternate hypothesis could be only in one direction, right? And then for two-tail tests, we could have both directions, basically saying that could be greater than zero or d could be less than zero, and yeah, respectively for one tail, it could be that d is not equal to zero. So this is the whole process of since I mean the whole formulation of A/B tests from start to finish is that first of all we identify an area and hypothesize it. So for example, it could be that for example there are navigation bars on e-commerce websites, right? So I could have an example. I could have a hypothesis saying that let's add a filter to the navigation bar so the users can easily filter all of the navigation filters. So it could be the color of the product, the specifications of the product, right? So the hypothesis could be that. So it's basically coming from the stakeholders from the business side or any of the entities, depending on certain organizations, it could be different. So basically, someone hypothesizes a particular scenario that, okay, let's do this and let's see if it has an impact on our revenue and let's conduct an A/B test for that. Then what we do is we get a baseline of the current metrics. So we get the current data of, okay, so for the past 10 days, or I'm just giving an example, but for the past 10 days, we've been observing the conversion rate for the control treatment to be this much. It's like possibly 6% currently for the past 10 days. So we can define our all of our expectations basically according to that baseline. And that expectation could basically be intuitively called an MDE, which is again the minimum detectable effect, as we discussed earlier. Then after that, there are discussions with stakeholders, and the discussions could be about how to implement the experiment because the experiment obviously has to go through a development process for front end engineers to develop it and implement it. And then there could also be a whole lot of scenarios to discuss. For example, what are the backup plans? Um, are there any data warehouse experiments that are being monitored for that, and all of that sort of stuff. Then the main part comes in, which is to design and develop the required changes. And this is where the front end engineers and the development teams come in. And then, so for example, it could be if the button is a specific color and we need to test if there's a change in the color, does it impact on the revenue? If this is a hypothesis, then then the developers will go and implement that button. Or it could be a whole page overall revamp also, right? So it depends from test to test. Then we collect the data, and determine the sample size, and then the test goes live. So what I mean by the test going live over here is that the test can go live for 10 days, for 20 days. It could go on for a long time as well. As long, I mean, it totally depends on how long it takes for us to reach statistical confidence enough for us to say that, okay, now we can make a decision that this is the difference. Because the worst case scenario would be that you did all of this and you conducted an experiment, but you didn't run it for enough days for you to even say that there's enough data. And eventually, when you get the data for the conversion rates, you say that, okay, there's not much difference. But you don't know why, because what the actual thing that could be happening in the background would be that you didn't have enough data for you to even say that there's a difference, right? Or there's not a difference in the first place. So we stop it after significance has reached, and analyzing the result to draw conclusions. This is again a test that vary. This is again a step that varies across different organizations, and analysis could range from a lot of things. It could be a funnel analysis. So I think we discussed about the funnels earlier on. I'll just open that slide again. Just a second. So as you can see, we have the funnel over here, which is from the landing page to maybe the catalog. The catalog being where all of the products are listed, and then the product page being where the details of a particular product are mentioned with all of the specifications and reviews, and then the cart page being where you eventually add it to the cart, right? Payment page being where you make the payment. So that's basically a funnel analysis, and further analysis into the results of after the data is gathered could be that, or it could be a lot of other things depending on the specific person who is analyzing the test. Or it could also be that this whole step is also skipped altogether. A lot of organizations don't do this because they prefer to conduct as many tests as possible and just stop it if they just see if the confidence level according to the data that we have, if we rejected the null hypothesis or not, and then they implement the winner or don't implement the winner according to that. So it depends from organization to organization. Coming to the next point, yeah. So implementing the winner would be if the treatment recipe um, depicts a huge change, right, or a favorable change, or a change that we can say is statistically significant, then we can say that that recipe won, and we can implement it. And so future possibilities could be implementing it, or implementing versions of it, or implementing other A/B tests based on that version so that we can get more clarity. Or it could be that we fail to reject the null hypothesis, and so we just keep things as it is, and we just keep the control experiment. I have a real world experiment going ahead, and this has been cited from this website here called HubSpot. This is their own A/B test example. So what they did is they tested three variants, and they've also explained how they reached to the conclusion of implementing a particular hypothesis. So they saw that non-bounce desktop users who engage with the search, um, non-bounce desktop users being the people who actually engage with the search, the search CTA, and they don't just leave the site without even engaging. So they observed that people who search have a higher conversion rate than those who don't. But only a small portion of the traffic intersects with the search bar. So they tried something so that the traffic for this engagement of the search bar can be increased. So what I'm guessing the metric for them could have been the engagement with the search bar along with the conversion rate. Um, Either of these could have been the primary or the supplementary metrics. I hope I'm not running too late on time, but I'll anyway continue. So if I'm too late, let me know on. But yeah, so
Yeah, we
going
are going
ahead,
good. Yeah.
basically, HubSpot decided to see the visual prominence and the influence on the functionality of the sidebar. So they implemented three recipes and they changed the words inside the search bar for a few of them, and then they also changed what the results would output basically. So for one, they had the whole site, and for the other, it had just the blogs. So what they observed was basically that variant C showed a 3.4% increase in conversion, and 6.46 increase in users who engage in the search bar. And from practical terms, these both these quantities are really really high when it comes to practical implementations of A/B testing. So that's a really good result that they got, and I just thought I'd share this example with you. And yeah, I think that is the main gist of A/B testing as a whole. And I do have a few more points to add, which would be there are a lot of mistakes to avoid. So basically, what many marketers do is that they don't let the tests run their course. So that's what I was explaining earlier as well. If you don't let the test run its course, then you don't have enough data to even statistically say anything. And for this, you can find many online calculators to determine if you've achieved significance or not. And yeah, if it depends from person to person or entity to entity how they implement it. Um, then comes the second point, just tracking more than one metric at a time. So in a lot of cases, what happens is people define a lot of success metrics. They say that okay, it'll be good for us to have conversion rates also, AOV also, probably more exit rates also, more click through rate also, and then a whole lot of other things. So I feel, and it's better in general for a particular test to just have one or two, not more metrics, so that you actually also know what you are testing, and the risk for unreliable or incorrect judgment is just decreased that way. Testing at the wrong time. So this is something that, for example, there's a specific period that you think has a different impact for consumers in for your target population, right? So this could be the holiday season. So it could be that for your specific website or any entity that you are, depending on the organization that you are in, it could be that the holiday season means more data for you. Or it could also be that the holiday season means less data for you. For example, if you're an education related website, that's just a vague example, but that could be an example for less data in the holiday season. And so testing at the wrong time is also a thing that to keep in mind of. Also, both the tests, meaning both the samples, should obviously be implemented at the same time simultaneously. So all the factors are equal. Testing too many element variations together is also a mistake, because then you can just create a lot of chaos, and it will be difficult for you to pinpoint all the elements that influence the test. And it could be that it was just a fluke that this particular sample worked for you, even though we have statistical significance, because you have so many elements, you don't know which one worked, right? So that, and then the last point being inaccurate audience sample size. So again, in inaccurate audience sample size, there could be times where you don't have enough data, and then you have to run the test for a longer time for you to get enough data. So it's related to the first point as well. But to get reliable results, you should always do that, and you should also always split your audience the right way. So mostly it's 50-50, but it could depend from test to test depending on this particular scenario. And again, there are a lot of A/B testing tools for this also, online, that you could find for splitting the all of this. So this was frequentist A/B testing. I just have a couple more points, not many, but it's based on Bayesian A/B testing. And the reason I'm introducing this is because a lot of organizations have started implementing Bayesian more than frequentist, because Bayesian is based on the concept of having prior data. So if you're at all familiar with the concept of the Bayesian rule, right? So the Bayesian formula, if you read statistics at all, would be that we consider a prior, and basically our result is based on a prior that we took, and we have to assume a prior, or we can set a prior, or that could also be something that is dived into a lot of detail later on. But for an overall just purpose, I would say that Bayesian differs from frequentist with the purpose that we have prior values here, and frequentist doesn't have that. If you look at the formula on the top right, this is the formula for Bayesian. And you could maybe recognize this from your statistics studies or maybe in school from mathematics. But this is the formula. The three terms we'll be considering here are the prior, the likelihood, and the posterior. So the prior and the posterior are these two, and then sampling or likelihood is the same thing. So I won't go into the formula because it's a derivation, obviously. But basically, how it happens is that you simply update your beliefs after considering new evidence. And what happens is your earlier posterior becomes your new prior. So posterior is something which you get after calculating the evidence and prior together. And then after getting your posterior, you can conduct another study and your posterior becomes your new prior. So that way, the main advantages of Bayesian A/B testing could be that you can reach to a statistical significance quite early compared to a frequentist A/B testing approach. And again, as we can see here in the third point, or sorry, the second point, frequentist inference returns a number or an estimate. So conversion rate was the estimate that we were considering earlier, and conversion rate is just one single number. But for Bayesian, what we do is we return probabilities. So everything that we're considering is through distributions. So that's why what you see here in this GIF is that we have three distributions, and everything is based on these probability distribution functions. And so it's based on a random variable and not just one particular fixed value. The third point says that as we acquire more instances of evidence, our prior belief is washed out. So, what this means basically is if you observe this animation over here, um, the prior is the graph in the red. And as it starts, you can see that the red graph starts on a horizontal line. And that's just basically us assuming a very weak prior that we don't know anything. And so that is how it happens. And as we get more and more evidence, the posterior starts becoming influenced by the prior. So, but if the prior is very weak, then initially the posterior will be influenced by the likelihood, which is the blue line. So, if you observe closely, you can see that the posterior and the black and the blue graphs are overlapped in the beginning. That's because we had a very weak prior, which is the red graph. But as soon as we start getting evidence and our prior becomes strong, the posterior starts mimicking the prior basically. There's also a point saying that as and as you get more and more data, your Bayesian results start mimicking the results of a frequentist test. So, yeah, I would say the main advantage would be to, from what I have researched, the main advantage would be that you can get statistically significant results much earlier than the ones that you get for frequentist. And yeah, that is basically it. And these were both of the basic concepts, frequentist and Bayesian. And we're pretty much done here, I think. And yeah, I think Aeon, you can take over, and I'd love to answer any questions if there are any.
Sure, sure. Thanks, Ishika, for I would say a lot of the questions that we already got from the community members prior to this event uh, have been covered in the entire talk, like which most of the questions were around, okay, we have this A/B testing and all those stuffs, but which are the major mistakes that I should be very aware of before starting with these things, or some things like that. And we also
Right.
covered on a lot of other aspects. So kudos to you for making such a presentation where we could cover the questions which are really important and which really make sense from I would say from the statistical part as well as the layman understanding of A/B testing as a I would say as a skill or as a project to do. So one question maybe we can pick up before we end the day because that question has been repeated a lot of times. So it's like students who are going for their internships or students who are going for their fresher jobs, they like they might want to do a A/B testing project, or they might want to showcase their skills in this direction. So would you have any suggestions for them? Maybe they can pick up a Kaggle data set, or maybe like how they can present this skill set of theirs to the potential employers, that okay, hey, see, I have done this. And because through your presentation it was quite clear that which things we should keep in mind, which things we should not, we should be very aware of, and all those things. But would if you can guide them around like how they can portray their project on the resume around A/B test, or like how would the things be? So that would be the only question that I think needs to be addressed. Otherwise, your session has addressed already the questions that we have got from the community members.
Right, right. Thanks for saying that. I'm glad it covered most of the questions. And coming to the one that you just mentioned, so if I would have been at the asking end of this question also, right, I would have
Mhm,
not wanted to hear this answer that I'm going to give now. But
mhm,
it would basically be that to depict A/B testing as in the form of a project, it's a lot of heavy statistical research
correct.
or
Mm,
knowledge in general, right? You can't really simulate the environment that you get from an organization or the
mm,
kind of data that they get. But what
mm.
you can do is just use NumPy, create
Correct.
a Kaggle notebook, create random samples, and then show that through your notebook. But
Mm,
then, since that is also really common, a tip that I have is again just depicting the knowledge that you have in some way or the other. Just writing blogs, maybe,
mm, mm,
because what I would also not want to hear is that just make a Kaggle notebook, right? So
mhm,
there could be a lot of many other ways for different projects, but for this particular scenario, since we don't have that data at hand, this could be the only way. And I think, to an extent, like, organizations understand this. They understand that
correct.
if the
Mm,
person hasn't had access to that data, then how will they even be able to do it? And even if someone goes and does something, like, okay, I did something, I have this data, they'd have a lot of questions around that, that how did you
mm,
even simulate something? Because
mm,
as you must have observed, most of the assumptions are largely just based on enough sample data, and that is the most important thing here. So yeah, that is what I would like to say.
mm. Makes sense, makes sense, because the organizations are quite cognizant of the fact that in order to run these kind of experiments, you need data in hand. And
Right.
definitely, even if you create those data, there is always a chance that you might miss the actual learnings from the experiment. But like as suggested, like blogs and other stuff definitely is a very good way to express your domain knowledge around this. And it's also about when in an interview, like Ishika can add. So whenever you go in an interview, they do not want you to go, like they do not want you to open the project that you have done and walk them through the entire process. They definitely want to understand what was your logic behind it, and do you actually know the process that's being followed, right? So they are
Exactly.
more interested into that, and if we are more clear onto that aspect, that would help. And like, thanks Ishika for the answer. And the community members would really appreciate if you could share the slides and
Sure, sure, yeah.
with them. So I
So
will get back to you
yeah,
to get the
what
slides, and I
I'll
will
do
update
is,
the links. Mhm.
sorry, yeah, sorry for cutting you off. What I'll do
Uh-huh.
is I'll add all of the references that I referred to, because I feel
Uh-huh.
that is important, because
Uh-huh.
obviously no one can just completely
Correct,
gather all of
correct,
the information from this. I'll
correct.
add those and then send those to you.
Sure, sure.
And
And then we can
yeah,
give the
yeah,
link to the community members from there. So no
yeah,
worries. Like we will be sending the speakers slide link within the next 48 hours, maybe if
right,
that works.
right.
Yeah, sure. Thank-
One tip that I do have actually for interviews is that it's very generic. It's not related to A/B testing at all. Is that just try to put yourself in the place of the interviewer. I don't know if it'll be hard for people to do that, but just try to imagine if you're the boss, would you be liking this person? And because there could be a lot of ways for you to present, and communication matters a lot. So it doesn't matter if you don't have a lot of projects, but as long as you have the knowledge and you can communicate in a tactful way, that I'm not saying that you have to like mimic something or
Hmm.
use malicious means, but I'm saying that just learn how to be in their shoes first and see what you would like to hear, and then that would help you a lot, because I'm saying that from experience, personal experience, because that helped me also a lot.
Correct,
And
correct. So it's also about like helping the other person understand that okay, you know the things and you are communicating it, and also communicating it in such a way that it really answers their question rather than only making round and round around certain things without giving anything solid to someone, right?
right, right. And
Correct.
lastly, it's just I just like to say that anyone who'd want to connect or would want to ask any more questions about this, or apart from that, collaborate on something, just reach out to me on LinkedIn. I'm sure Ion has attached the links on the bottom.
Correct. Correct.
Or
Yes.
you could, yeah, or you could reach to me through my portfolio site as well. I'll have that linked as well if possible.
Sure, sure,
So
sure. Do send me, and I would be happy.
yeah, and thank you everyone for whoever joined or whoever watches this later on as well. This was my first first webinar so, like this, but yeah, I'm really glad for the opportunity. Thank you.
Thanks, Ishika. And we are based out of Delhi NCR itself. So as
Yeah,
soon as we organize a offline event, and I also see that you are in Delhi NCR region, in case
right.
you happen to be there while we plan the event, we would be very much happy to host you in an offline session also. And the community is a great place to learn. We all have learned through this. Thanks, Ishika, for the support to the community, and we wish you all the best for your future ahead.
Thank
Thank
you
you,
so much. Thank
everyone.
you. Thank
Stay
you for
safe.
all that you've done. Yeah. Thank
Yeah,
you.
thank you. Bye bye.
Bye bye.